Thank you, thank you. Amazing intro there, by the way. That was really good. Uh, Thanks everybody for joining us. And my name is Larry Waters, if you haven't heard that already. I've been around the HVAC trade since 1982, back when we were using duct tape, the kind you fix windows with now, to actually put ducts together. And back when I started, the drills had cords on them. I'm a NATE certified technician. That's North American Technician Excellence. If you don't know what that is, it's kind of like the ASE is for the garage mechanics. And I'm also a BPI certified building analyst from that's Building Performance Institute. And that's kind of the study of building science and how houses interact with each other and that sort of thing. I got really super dialed into installing heat pumps back in 2015 when I was working for another company before I started this company. And at one point, it was so bad, my boss is just like, "Can you sell a furnace, please?" And so I really got into doing that because we were making houses tighter and making them theoretically smaller, and we didn't have furnaces that were small enough for the houses after we made them tight and energy efficient. So with that knowledge, kind of moved forward, started my company in 2020, Electrify My Home, because I just wanted to do heat pumps. I wanted people to call me that knew what they want. So that's worked out pretty good. Okay. Oh boy. Okay. All right. Our mission, I always share our mission statement. Our mission is to provide the most efficient, cost-effective electrification solutions to California ratepayers and practice good stewardship of the electrical panel, which really is what we're going to talk about today. Like, how do we electrify a whole house on an existing panel? And how do we know when it's time to get a new panel? And how do we add that circuit? All these things we're going to talk about today. And that really rolls into that whole ball of good stewardship of the electrical panel. And the bottom part's pretty obvious. That's what we're doing here today as well. I want the electrification in California to turn out as good as possible. So having as much influence as I can on people to do things a little bit more efficiently, like electrify efficiently, is really important to us. So that's why I do this. And it's not just to hang out with great people from the utilities. So um, we're going to talk about importance of the panel, what to think about before getting a panel upgrade. I'm going to offer up some pretty cool solutions to capacity challenges and some of the tips and tricks and strategies we use to keep it within the electrical infrastructure that's already in the house. And at the end, I'm going to show you some case studies and some real world examples. And it's going to be awesome. Just hang on to your seats, people. Okay, so next time when we come around in May 6th, it's going to be products for the Central Coast. And then in June, we're going to be doing optimizing heat pump zoning for maximum comfort. And those are really good ones, especially if you're into like installing heat pumps and you don't know whether you want a mini split or a ducted system or kind of just wondering what I'm going to do with those two stories. That optimizing heat pump zoning class is really, really a good one. So we'll have a we'll have an expert in from one of the manufacturers and he's going to kind of tell it like it is. Okay. So what is the importance of the electrical panel? Well, it's only just everything we deal with, right? So, oops, I moved the screen wrong. No, I don't want to leave the meeting. I want to go like that. There we go. All right. You know, I am not the youngest guy here. I have had a computer since I was 35 years old, so there was no excuse for that. Okay, so importance of the panel. So this is meant to be very dramatic. Okay, the electrical infrastructure is the brain of electrification in your home. Heat pumps are the heart of electrification. And my message is just like we do on our bodies, we want to take care of our homes like we do our bodies. So make sure you use the right heat pump for the right application and don't fill your brain full of a bunch of garbage. So I'm not telling you can't scroll through TikTok videos. That's up to you. But let's not fill the electrical panel with a whole bunch of stuff we don't need to. So, all right. So the big question here, just looking at these electrical panels, and I don't know what the reference point of our audience is today, but I got a couple of electrical panels here. A couple of things about them. They're completely full in one way. Like there's no space for anything to go in here, right? I can't just take an empty spot and throw a breaker in there. So my question is, are these panels full? And the answer is, I don't know. We got to figure it out, right? And we're going to do that together. So, first of all, we need to get some of the basics going. This is called the power law. And the power law is this thing, everybody should know that what voltage is, right? Voltage is the little plug that you plug your razor into. That's 120 volts. We all know that. And I will take 110, 115, 120. When you're my age, all those answers are correct. And then we got the big plugs where your dryer plugs in or your car charger or something big plugs in. Those are 240 volts. Generally, air conditioning systems on houses are going to be 240 volts. Things bigger loads like car chargers, dryers, that sort of thing, 240 volts. So we have the two voltages. And then we have the watts, which is the power, and then the current, which is the amps. So different appliances are going to have different requirements for power, and they're going to label differently. Like your dishwasher and your microwave might have the power listed two different ways. One might say amps, one might say watts. But in order to do what we need to do, we need to know what the watts are of different appliances. So we can get any one of these by just playing some magic with the other two. So if I want to know what the watts on an appliance is, and I have the ability to see what the amps are with like an amp probe or an amp device, a meter, I can figure out what the watts are. If I know what voltage it is and what the amperage is, I can times those two and that'll give me my watts. If I want to know what the amp should be, I can divide watts into volts. And if I don't know what volts are, I just need to look at the plug size. So that one's real easy. Okay. We don't really need to do the math to get to that one. So here's important concept number 2 is be careful. You can get shocked. Don't service an electrical panel in bare feet with a wet sidewalk. Not a good idea. But also don't fear the panel. Have a healthy respect for it. Electricians are really smart people, and they just know they have to have respect for it, right? So it's important also to know if you have a 100 amp panel on your house, it has the ability to deliver an incredible amount of power, like 24,000 watts. That's a lot of power. And so not all the power gets used at the same time. So it gives us some leeway on these things. If you have a 200 amp panel, well, you guys got some big houses out by you. So 200 amp panels could potentially be full. But up where we're at in the Bay Area, if you have a 200 amp panel, you've got space, right? Unless you live in a giant mansion. So, but that's 48,000 watts. And most of the time when I'm electrifying a home, if it's a modest size house, I can do it on 100 amps with no problem, including everything we need to do. Let me show you. We're going to show you how to do that. Okay. So what that means is it's a lot of capacity. Excuse me, I need a cough button. There was a study done by this group called Home Energy Analytics, and they looked at 22,442 houses in California. They didn't know what size panels these were. They only had access to the meter data. And so what they found when they looked at this is 98% of the houses out there never went over 88 amps. And remember, we're talking about 100 amp panels. So 98% of all those houses never went even close, really, to 100 amps. 86% of them never went over 50 amps, and almost half of them never went over 30 amps, which just really means we have a lot of power in there that we can use before we need to start thinking about really costly electrical upgrades. So lots of unused capacity there. This is the kilowatt distribution kind of graph for a couple different types of houses. Over here we have they looked at 7,000 houses in the SMUD territory that were all electric. And then they looked at a bunch of mixed fuel houses, way more mixed fuel houses, obviously. But what they found was the demand curve is a little bit different. We're going to use more energy with electrical. We're going to spread that usage out, but our peaks are not going to be much different. So remember, a 24 kilowatts, 100 amps, 240 volt, and we're falling well short of that. And there's only a small number of houses that ever get there. So there's a lot of power out there that we can harness and use if we do it wisely without that costly upgrade. So here's a house here. I don't know if you guys see Alex on the call. Alex is the operations manager, the second guy here at the company. And his house is built in 59. It's 1,420 square feet. It's up in Davis, California. So it's not it's not like it doesn't get hot up there. And we were able to put a 2-ton Mitsubishi system in his house, and he will tell you if you ask him that that system is probably a little larger than it needs to be. He has a 50-gallon heat pump water heater, an electric range, an electric resistance dryer, and he's soon to be installing a car charger. But his power, his peak power over a whole year's time, maxed out at 6.56 kilowatts. And remember, we have how many kilowatts in a we have 24 kilowatts available in a 100 amp panel. So he's not getting anywhere near that. And he's living in a fully electric home. And while Alex is one of those guys that probably doesn't intentionally try to conserve, but he's a guy that doesn't, he's got a low footprint in life, which is kind of cool. My house, I have a little bigger house in Vacaville, still super hot. And I have like an extra heat pump in my garage and multiple refrigerators and a whole bunch of stuff. And if I turned everything on, I tested it one day with the stove on, max, everything, I was about 10.5 kilowatts. So still well less than the 24 that we have available on a 100 amp panel. Okay. So we don't want to fear an electric home. We want to just treat it nicely. We want to whisper to it and we want to say, hey, we want to put the right size system in your house. And in order to do that, we got to make it a little nicer and a little tighter, a little better efficiency and a little better insulation, seal it up a little bit so I can get a really, really efficient heat pump system in there. So maybe my house only peaks out at 6.5 kilowatts. Okay. So just with that little bit of information, so are these panels full? Excuse me, cough button. So it's still a little bit of it depends, right? We have to follow electric code. Once you get really good at like looking at these panels and kind of sizing them up, you're going to understand this panel on the right here, this is a 100 amp panel. This one's a 200 amp panel. Okay. What we have in this panel is a lot of individual arc fault breakers. Boy, that can be messed up really bad. Arc fault breakers that take up a fair amount of space. There's nothing we can do about those. So those are taking a lot of space, but they're not using a lot of power. And then I have a double breaker here for the dryer. That's a 220 volt breaker because it's going off of two sides. Okay. Anytime a switch is doubled like this, it's double the power of a single switch. These are always going to be 120 volt, and these are always going to be 240 volt when they get there. This one we have here is what this quotes call a quad breaker. And this is two 220 volt loads on one breaker. And down here, I've got some tandems. These are small breakers that are the same size as this. So they're only hitting one bus bar. So they're 120 volts, but there's two breakers on each. And they do that to save space because of all this room we had to take up here. The only single 120 volt circuit we have on here is the dedicated furnace circuit. We can't really do anything about that if we're adding a 220 volt load. But we do have opportunity in this panel. We'll get on beyond that. Over here, 200 amp panel. I think it says 200 on there. This is the first time I've seen this big enough that I can actually see the breaker size. 125. All right, I've been saying it wrong the whole time. So 125 amp panel, lots of power on there. I got a couple of 220 volt breakers, got one here, and one here, depending on what those loads are. And then I've got a bunch of larger breakers here, and these breakers can easily be removed, and we put in like a quad breaker or something. So we'll get them onto that a little bit more in a second. What we have to know is just because all the breaker space is taken, are we at capacity? Because there's a full panel and there's an at capacity panel. So those two things are not the same. One of them means there's no more space. The other one means there's more power. Okay. So we must follow the National Electric Code on this stuff. Now, a little bit of optimism. In two code cycles from now, they're changing the code to better reflect more efficient appliances. So in 2 years from now, it's going to be even easier to do these, but we still stuck with the old stuff here. So there's rules in place to prevent overheating of the wires in the bus bar. So the reason they have the breakers and the reason they have the power loads is because we don't want to melt the wires inside in the wall and cause a fire. That's why we always have to have the right breaker and wire size have to be sized properly. So we don't want our breaker to exceed our wire size or our wire's capability of carrying that much power. So when we're doing load calcs, we have two options. Haven't seen where we could use this one yet, but there is in the electrical code, there's a top-down method. And what that means is you can use the metered or billing historic peak, like we saw with Alex's house, with that 6.25, and we can multiply that by 125, and then anything above that is available. Okay, so then you have to use the full nameplate rating of all the new proposed appliances. We don't get a discount on those. Okay, that'll mean something in a second. The bottom up method is what we always use and what most jurisdictions are going to use. They're going to give you a form you have to fill out. Some of them are like PDF, fill out online, super easy. Some of them are a piece of paper and you got to give it to them like a caveman. What we have is the nameplate loads and demand factors are considered into this. And what we mean by demand factors are also called coincident factors. And what that means is not everything's going to run at the same time. So we get to discount a bunch of the loads in there. So most of the loads in your panel are going to be at 40% of what they actually are, which means I can put a lot more capacity in there than space, because I'm really only counting most of those loads as 40% of what they say they are. Hopefully that made sense. Okay. So here is a example of a load calculation and what we look for and some of the outliers that are going to be in here. Larger houses are going to have larger loads, even if they don't have as many appliances, because the first thing we have to look at is the size of the dwelling. So we have to take the square footage of the house, and this makes it real easy on small houses, 1,000 square foot houses, 1,200 square foot houses, 1,400 square foot houses. That keeps this first number nice and low. But when we're talking about a 2,350 square foot house, we have to count 3 volt amps or 3 watts per square foot, and that gives us 7,050 that we need to start with. If you think about it, on a 1,000 square foot house, that's going to be 3,000, so it's a lot less, right? It gives us more room on the other end. And then we have kitchen and small appliance circuits. We need a minimum of 2 of those. If you've had a great big house, you got a great big panel, you got a lot of kitchen circuits, you should add in for other ones, but they ask for 2 kitchen circuits. This is why if you're using your espresso machine and your toaster oven on the same plug, it blows the breaker. Plug it on the other end of the line. Maybe you can get on that second circuit. Then we need to include that laundry circuit, which is a washing machine. We're gonna think everybody has the ability to get a washing machine. So there's 1,500 watts added in for that. And that's going to be the general light and plug load. That's what's going to be the basis of our load. Then we have to add in all the appliances. So if we have a built-in microwave, we have to go to the label of the microwave, see what the output of the microwave is, and then put in the watts here. So this particular one was a 1,200 watt 10 amp microwave oven. So we got to slide that in there. Dishwasher, 1,800. Garbage disposal. It's funny because these run the gambit. Like if you're going to the hardware store and buying a new garbage disposal, if you think you're only going to grind up enough eggshells that you need a 0.5 horsepower, get a smaller one, because that's going to count later if you ever have to do the thing. If you get a 1 horsepower, it's way more wattage than the smaller one. So think about that when you're doing that. If you have a refrigerator on a dedicated circuit, we have to add that in. If it's not dedicated, you don't need to worry about it. Stove hood, if that's dedicated. And then like this particular house, this is a fully electrified home. So they have the Frigidaire Gallery 30-inch front control induction range with air fry. I like how they put all the options in there, right? So that thing's big load, 10,080. They got the heat pump dryer. They're doing a little bit of what we call watt diet on this. They didn't go with a regular dryer, which would have been about 6,000. They went with a 240 volt heat pump dryer. And there are 120 volt heat pump dryers that are actually even a lower number than this. And then they've got the 15 amp, 65 gallon water heater. This is a 220 volt model, but it is only a 15 amp model. So that's a special purchase. You could also go with a 120 volt. But then what we do is we take all these numbers and we add them all up. 32,730. And man, you're going, Larry, that's way over 24,000. And so hold your horses. This is where it gets good. So what we do here is we take the 32,730 and we just take 8,000 out of that. So we subtract it from the 32,730, our 8,000. This is our basic load that's really disaggregating all this down to 8,000. Okay. And then so we're going to take the remaining number from 32,730 minus 8,000. We take that remaining number and we times it by 0.4. And that's our coincident remaining VA load. And that brings that big number all the way down to 98, 92. So we've got a lot more power in this panel than we think we do, right? So my general loads total are 17,892. They had a weird bathroom heater in this house, so that was 1320. We have to add that back in. And then we added in the Mitsubishi HVAC system, and notice 2,300 square foot, 3 ton. That's nice, nice downsizing. That's 4080. Our secondary loads here, we add them to this. And even with this fully electric house, and I'm going to show you kind of the cool thing here in a second, but with this fully electric house, we're at 23,292. And not to be forgotten, we have the electrical charging, the electrical car charger here too. But what they did is they used a circuit pausing device, which is a device that we use a lot. And basically what it allows it to do is the circuit pauser says, if my panel gets up to a high load, it just won't let that load turn on. So we don't have to count that load at all, right? So we're saving a 30 amp electric car charger just by pausing the circuit, and we don't have to account for that. So we've got some really good watt dieting going on in here, and my fully electrified house is only 97 amps. I got a 100 amp panel. I'm good to go. I'm clear. We're sliding right into the building department and waving this thing in front of them going, we did it. Okay. So what's wrong with panel upgrades? Why wouldn't I just want to get a panel upgrade and not have to worry about filling out a form that's going to take 20 minutes? I could just do that. If I want to spend, between $4,000 and $10,000 on a new panel, and much more if you need like additional infrastructure, you got to move the thing down the wall. These things can get really, really expensive. There's another thing about putting a panel upgrade in is if you're living in an older neighborhood, especially if your wires are coming from overhead, there might be a chance where if you got a 200 amp panel upgrade, they would have to do a engineering study, first of all, to see if you do it, and they might have to upgrade the wire on the whole street just because you thought you needed a 200 amp panel. And there might be a guy down the street that has a 60 amp panel that needs a 100 amp that won't be able to get it because too many people on that street got a 200 they didn't need. So it's a bit of a societal good for not doing it if you don't have to. So keep that in mind. It can also get complicated and really expensive if that panel is near that gas meter. So we've got projects out here where we had old panels that needed to be replaced because they were just kind of old and kind of rickety. And what we did is we did a temporary full electrification on the house. We had the panel removed, or we had the meter removed, and then we were able to do more work nearby. Because otherwise, the utility company wants you to move this thing all the way down the wall. And it's not that easy to get these wires from here to over there, and they don't want you using this as a junction, but there's a whole bunch of rules, right? So if we can avoid that, it's great. Let's try to avoid it. At least until you electrify everything, get your gas meter removed, and then you put a nice shiny new 100 amp panel in here, you'd be good. You got new technology. It's all new. It's going to last another 70 years. And, but it's a lot easier to do if that gas meter's out of the way. Okay. What the things we can't control as a homeowner. So what you see here is a whole bunch of blue stuff and a whole bunch of red stuff. The red stuff is what you're going to pay for. The blue stuff is what the utility company cares about. Okay, so this is all their stuff. This is all your stuff. They care about how their stuff connects up to your stuff, so they get a little dodgy about it, right? So they own PG&E or Southern California Edison, any of the utilities, they all own and they're responsible for all of this side. So they're really careful. So if you have a house here and you want to upgrade this to a 200 amp panel, they have to make sure that this wire is adequate for 200 amps, and they have to make sure that this transformer is adequate for 200 amps. And they don't even know how many people on your street might have got an electrical panel installed without a permit, which is something you never, ever, ever want to do. Don't get an electrical panel upgrade without a permit. It's just not good. It's not a good thing for the grid. And then you're responsible for all this. So if you need to do a panel upgrade, sometimes the panel needs to move down the wall. You need a whole new mast. You got to run the wires out here. It's going to get very expensive. And then they got to come back and say, oops, you moved it too far, or they're going to tell you where to put it, literally. And then the service line might have to be upgraded, and there's some additional expense involved. So anytime we can avoid this, we're much better off. Okay. I think I beat that dead horse pretty good. So electrical service upgrade steps. If you're going to deal with this and you're going to get that upgrade, these are some of the things you have to deal with, right? And so I've got an upgrade right now that's waiting, and has been waiting for over 10 months to get upgraded. And I could go into that whole story, but we potentially don't have time for that today. So you do the planning phase, you go out, you take all your pictures, you go on the website, you put all your pictures in, you fill out your forms, you do all your stuff. And that takes 3 days for you even to get an email back. And then they can say, hey, you're in luck. You're the one guy that we've never had a problem with. And we can do this really fast. Or they're going to say, you know what? We got to do a load assessment. And that's going to take 30 days before you hear back from us. And then in PG&E territory where we're at, if you miss an email from them and 30 days elapses and you don't get back to them, they make you start over. So good luck with that. Then they're gonna tell you, oh, we need to do an engineering survey potentially. That could take 75 to 100 days, and we need $2,500. And then so you got to shell out $2,500 that you may never see again, and just to find out if you can get down the next piece, right? So this is all grief and delays and all the problems you have. If we just take advantage of the power that's there and make smart decisions, we can kind of avoid all this. And then it says construction and energization, um, 42 to 84 days. That's kind of low. We were doing one the other day and they got overloaded. My guy's out on the job site, is going to switch the power over that day. We took the time to get the city lined out with the PG&E people or with the utility people, and the utility people called and said they overbooked that day and they couldn't do it. So customer has to wait. We got to wait. We got to send a guy back down. Not like our guys aren't scheduled out 2 weeks in advance. And they said, we can come back Friday and do it. And I says, yeah, but we can't. So try to avoid that. It's just a bunch of headaches you shouldn't have to deal with. Okay. So solutions. What do we do to get this done, right? So if we're going to electrify a whole house, most houses from converting from gas, depending on how many gas loads they have, are going to need a bunch of breakers put in, right? So this is the one that we can really do well as heat pump installers. If we install a single low energy inverter heat pump that's properly designed for the house, that's going to be one double pole breaker. And in other words, one breaker here. That outdoor unit is going to feed power to the indoor unit. So we're being good stewards of the electrical panel now, right? We're not taking up 6 spaces potentially that we need. And we're still seeing these 6 space systems be put in. And that's basically a wire for the heat pump, 220 volts, a wire for the air handler, 220 volts, and then a misguided electric heating element that goes in because the heat pump that was installed doesn't do a very good job when it gets below 40 degrees. So we're still seeing some of those go in, and there's so many options to avoid that now. So dryer is going to be 2 spaces or potentially a heat pump dryer that plugs right into 120. If you've got a little time on your hands and you're okay waiting 20 minutes longer for your clothes to dry, to mostly really dry pretty well. And then hot water. We can get 15 amp heat pump water heaters, or we can get 30 amp heat pump water heaters, both in the 220 volt version. But we've also got 115 volt models that'll go here. Our range, and this can be the outlier in a lot of houses. What throws us for a loop sometimes is those houses that have a separate cooktop and oven, because both of those things need a 40 amp breaker each. So that can really cause problems, and we don't want to share a circuit on a range. More about that later. And then EV charger, 2 spaces, 30 to 50. One of the things that we need to do when we're talking EV chargers with our customers is we need to find out how many miles they're going to drive a year and match the charger capacity to their mileage. They're going to be charging the car in the middle of the night anyway. They don't need a 50 amp charger if they're driving 12,000 miles a year, right? They just don't need that. And sometimes you got to talk people down because they want the fastest and the best, but they're going to be charging at midnight. They don't know if it's going to take 2 hours or 6 hours to charge. And frankly, a 30 amps better for everybody anyway. So these are the outliers. The range, if there's a separate stove or separate oven and cooktop, that can be an outlier, and the EV charger. Those are the ones that can throw us for a loop. So we got to start conserving power at this point. Okay. So here's one. The panel is full. There's no space. but it's not at capacity. So there's a bunch of stuff we can do here. We've got a bunch of these 120 volt wide breakers here. These can be changed with duplex breakers. So I can take four of these out, put in two duplex breakers, and that opens up a spot for a big breaker, right? I could take this big breaker out and I could put a quad breaker in there. So there's a couple things we can do around that just to manipulate space. But it's really important when you do this to look at the legend on the panel. Write down where you're going to be moving breakers to and readdress the legend in the panel so it is still accurate to what's going on in the house. Because so many times I've seen this where a pool guy or an HVAC guy, they just come in and start moving stuff around, and then the panel gets labeled all weird, and pretty soon you got a crazy labeled panel. I usually have a picture in this presentation of that, but we did one in Davis recently, and you could see there was like 4 generations of labeling in there. There was no way you could put any confidence in any of those circuits. So do your part, do it right. Make sure you know if you're going to be moving circuits around, relabel them. Okay. Some houses where we go to and it's an air conditioning house and the air conditioning is from the 70s, they ran 50 amp wires to those air conditioners. So most of the heat pumps we're going to put in nowadays aren't near that capacity. In fact, a lot of them are going to be 20 amp for the whole thing, depending on which type of system you use. And so what we've done a lot of is take that old air conditioning circuit and we just pop a sub panel in out there, and we can run multiple circuits off of that sub panel. So like a new 20 amp air conditioner or heat pump, excuse me, inverter heat pump, and then I'll take a 30 off of there and I'll run it back to the water heater if I need to, or dryer or whatever. Or you can just downsize the breaker on the other end if you've got space in the main panel, but this is a good way to do it as well. And then sub panels should never be fed with a wire size that's less than 8. And if you don't have a common wire on the outside panel, this needs to be marked no 120 volt circuits. Okay. So solutions to full panels. Once again, where are we? We're going to add this heat pump water heater circuit to this panel. We looked at this one earlier. It's got all these big wide arc fault breakers at the top. It's got, we try to never touch the solar PV breaker, but there's an opportunity we could quad this out if we needed to. I try never to touch the solar breaker though, because I just don't want to be part of that. But we have an opportunity here with our dryer circuit where I have some ability to add another circuit here. I could go with a quad breaker. So I could quad that out, but that's only going to give me one opportunity. So if I'm just running a heat pump water heater and I'm doing this as the first part of a project or the first phase, and I can run the power to the heat pump water heater off of here, and I can keep my dryer coming off of here, but that's going to fill my panel. And now the next thing I need to do, I've got the same problem again, right? So second thing you could do is potentially a circuit splitter. If the heat pump um, if the heat pump water heater is going near where the existing dryer is, or we want to utilize one circuit to do 2 loads, there's a couple options here. This is called a Neo Charge. This is a little unit that plugs right into your existing dryer outlet, and it gives us an outlet, a primary and a secondary outlet. If they need a 30 amp car charger, this is a great way to do it, because what it'll do is it just won't let the car charger work if the dryer's running. So as soon as the dryer shuts off, it'll allow power to go to the car charger and you'll be good to go. So you have two 30 amp loads off one feed and one wire and a whole bunch of not problems, right? This is another one we can do. This is one we use a lot here at Electrify My Home, is the simple switch. And the simple switch is a hardwired solution, a lot like the Neo Charge. And basically we would take the dryer circuit, we would run it into here, and then we would put the primary side into the dryer and the secondary side potentially into the car charger, then quad this out and use my center space as my heat pump circuit. But it gives us an additional circuit off of that. At least so we've gained one off of that same space that we would have just came off with 2. Hope that's understandable. The third thing is We could do a circuit pauser like was shown in there. So a circuit pauser, the one we always use, is the simple switch, and there is some CTs or current transformers that you have to put around the main wires coming in. And this senses the power coming or the panel is utilizing. And when the panel gets up to a certain point, it just won't let that circuit turn on. When you start using less power, when you've shed down some of your loads, maybe you're not cooking Thanksgiving dinner on your induction stove anymore, it'll allow that circuit to energize and whatever's coming off of that circuit will work. We use these a lot for car chargers. And we use these simple switches in this configuration a lot for sharing a stove with a car charger. Or if we're going to put in a range top, like they've already got an electric oven, and we're going to put in a range top, and we want to use the range top with the car charger. Most people aren't cooking and charging their car at the same time. That's a good option there. Or the circuit pauser. Now, we were going to do one last week, and it was the most unique one that we've done. And then we figured out this wasn't going to fit, so we had to upgrade. But we were going to take a sub panel because there's not enough room in the panel, run our car charger and our dryer off of a 60 amp breaker off of the main panel, and put a circuit pauser on that whole sub panel. So basically, if the house got up high, it just wouldn't let the dryer or the car charger work. And that allowed us to move a lot of load off the main panel. So everything fit into that load calculation. Now, those customers are never going to get to 100 amps. They're just probably never going to get there. So this is a good solution for that, because what this is doing is it's just saying, if I ever do get there, I'm just not going to let it go over. So chances are this thing may never operate in the entire time it's installed. Houses just don't get up that high. But remember, it's all about the wires, right? Okay. The other thing is a sub panel. This is probably what I would want to do on this one. I would want to put a sub panel in, do a calculation on the panel, find out what I have left, do a calculation on what I'm going to put into that sub panel, and run a sub panel with a big enough wire to handle whatever additional loads I'm going to do. And then you can even start splitting loads from that sub panel on. So there's a whole bunch of options here that you can do once you're there. But if you're going to do multiple things over time in the house, it's a good idea to kind of future proof some of it. Maybe we're putting in the heat pump now where there was a heat only house, and we want the power to come off of here for that. And we're going to have that future heat pump water heater, and we want to come off the panel for that. And I've got the dryer. Then maybe I could split off from there. But that's going to give me enough ability to come out and do the next thing without redoing this whole, like, where am I going to get the power process? So we can take the easy way out with the quad, or we can think about the future a little bit more and potentially do a sub panel or something like that. Okay. And then there's these amazing devices that we have that are called smart panels. And if you guys haven't seen these are pretty cool. This is two examples of smart panels. One's a little not as smart as the other ones. One's kind of like the less smart brother. Like, I have two dogs. One of them's an athlete, and one of them's really smart. A lot of families have that too. I had that in my kids too. But the span panel, a really, really smart panel. This is a load management panel, and it will allow us to put, almost as many amps as we need on this panel of loads. And then we can tell it what to do with the load if it starts getting up to the peak. And you can have a car charger on here that'll automatically throttle the load to stay within peak, or it'll turn the car charger off all the way if you get above peak. And we can add a whole bunch of circuits on this and not worry about it, because the panel is going to take care of it. And if there's an issue, it's going to send you a text message and tell you that, look, you can't charge your car right now. This also lets you track all your energy use for a long time. So it's got built-in circuit monitoring. It also has built-in battery monitoring and built-in solar monitoring. So it brings all of your electrical into one place for you to look at, and it allows you to turn on and off circuits. If your house is running just on battery, this will send you a text and say your house is running off battery right now. And it'll say, hey, if you turn these circuits off, we can get a couple more hours of battery use. But it's nice because it reminds you to go into human efficiency mode when your house is just running on battery. So not an inexpensive option. These things are around $10,000 installed with labor and all the breakers and all the stuff you got to do. But if somebody's considering putting in a 200 amp panel and they have to dig a trench in the yard and they're looking at a $20,000 upgrade, this is going to be a game saver because it's going to be a lot less money and it's going to give them really, really good control over everything in the house. So love these span panels. We do quite a few of these. Okay. What else can we do? We can just put in a shared circuit water heater, right? We can go with a 120 volt water heater if we size it right. Now we get into that whole thing. We could talk about that in a subsequent class at some point. But if you're going to put in a 120 volt water heater, I don't know how much anybody knows about water heaters here, but most heat pump water heaters have secondary heating elements. These, as a case, don't. They run off heat pump only. So they do have recovery time differences from traditional heat pump water heaters or traditional gas tank water heaters. So you do have to size these properly so the house has enough water. But this is a good option. Okay. So the other thing we need to worry about is safety. We talked about that a few minutes ago. There are some electrical panels out there that are notorious for being potentially unsafe. And I run into Zinsco panels out there in the world all the time that are fine. I always talk to my customer about them. Like, this is a panel. These panels were from the 70s. If you do the math, the 70s were 50 years ago. So you have a 50-year-old electrical panel. Nothing else in your house is 50 years old except for your house itself, right? So there is a point where it makes sense to change these panels out. But if you see anything like this, you have to change the panel out. You got to press on the brakes and you got to say, we got to figure out this panel thing before we can go any further. It's always got to be the number one thing is always going to be safety. So it's better to hold off on other electrification issues than to ignore a potential safety issue and get that panel replaced before you start anything else. And I don't know if anybody on here is old school enough to know what these are. These are called pushmatic breakers, and these weren't very popular. These breakers right here you had to use a screwdriver and take a screw out that was screwed into the bus bar. Now, that's a sketchy thing to do, even when you're a young guy and don't know what you're looking at. That's a sketchy thing to do. I haven't seen a pushmatic panel in probably about 20 years, but 20 years ago saw a lot of them. These are the stab lock panels. If anybody's done these are also called Federal Pacific. And the nice thing about these is when we see the arcing on these, we're going to see it up front and personal. Like, it's going to be right here. And then you're going to pull this off and you're going to see some arcing on the thing. But they tend to indicate on the lugs more than these Zinscos do, because you really can't see the lugs in these breakers. And so what we find is the arcing happens at the bus bar on these a little bit more. So you do have to, if you're going into a Zinsco and you're going to add load, just tell the customer you're going to turn the power off for a few minutes and check it out. Make sure it's okay. Okay. Enough of the safety. That's the safety meeting for today. Okay. So what are some solutions? Watt dieting. It's our favorite thing to do. Regular dieting, I don't like doing it, as you can tell. If I don't have full screen for that reason. I don't do a lot of regular dieting, do a ton of watt dieting. My wife will tell you that doesn't make the difference. Okay, so dryers. This is a biggie. You can get a regular electric dryer, which is going to dry your clothes pretty quickly. They do use a fair amount of energy. This is one of those loads where you're gonna have to say, we're gonna have to come to an agreement in this family and not dry clothes between 4 and 9, because that's just going to cost a lot. They're not going to work as fast as a gas dryer does, but they'll dry your clothes pretty well. But you can also get an efficient dryer, which is like a heat pump dryer. Now, if there's only a couple people living in the house, or you're super conscious about energy and all these things, heat pump dryer or a combo washer dryer might be right up your alley. They work really well. They just take a little bit longer to dry the clothes. Dishwashers, we can have the really souped up dishwasher with the sanitizing cycle, and we can have the one without this secondary built-in heater. This is the biggie here, the heat pump. We can listen to the wrong heat pump guy, and we can get a single speed heat pump, and they could tell you, on those cold nights, it doesn't work that well. So we're also going to put in this heater element strip. And then those things are like almost 10,000 watts. Or we can put in a really efficient inverter driven like a umbilical style unit where we're just running the power to the outdoor unit and it's powering the indoor unit, and we can get 3,500 watts with one of those. That's a big difference when it comes to calculating out these panels. We can go with a 4,500 watt 30 amp or a 15 amp 2,200 watt heat pump water heater, or we can go with the 120 plug-in if we size it right. And look at the difference in these two choices, right? If we give people bad advice on electrification, it's no wonder people need panel upgrades. They need panel upgrades because we're not advising them properly. So after this class, you guys are going to go out and advise everybody exactly right? Okay. So big difference here, like less than half if we just do a little bit of watt dieting. So it can be done. People are willing to make the sacrifice for the environment. So, and it's not that big a sacrifice, especially this heat pump, because this one's going to be way better than this one. This one's going to take a little longer than that one. Other than that, you're good to go. Okay. So here's some 120-volt solutions. If somebody just needs a 120-volt load and they just want to heat and cool one room, or if they want to run their house off a battery and they want to have HVAC, well, some sort of heating and cooling working, or they run off a generator sometimes and they want to have some heating and cooling working, these are amazing. These are 120-volt air, are just wall-mounted mini splits, and we can install this in one room. So if you're dealing with the customer that like has some sort of an illness or a disorder and they need to have the temperature the same all the time in the house and they're worried about that, just hook them up with one room here and it runs off the generator if they need it, and they've got a place to go to be safe, right? This works really, really good. Or in that case where we're doing a just a little ADU in the backyard and we don't want to run a lot of power to it, these are great solutions for that. We talked about the 120-volt heat pump water heater. And I'll tell you, I've had a heat pump. The only heat pump water heaters I have ever had in my house have both been 120-volt models, and they're fine. My showers feel the same. It's all good. Don't panic. It's gonna be fine. Just got to put the right size tank in. Then we have these amazing things now, which is wash and dry in one machine. The next generation I hear from this is going to actually fold your clothes, so you might want to wait for that one. I don't know. But if you're really a stickler for like I got to stay on schedule and get my laundry done in a specific amount of time, these are the same size as a regular washer or dryer in width. Like if you have the means, just get two of these and you could do two at the same time. Whatever it takes. But this is throw the dirty clothes in, come back 2 hours later, grab the dry clothes out. We live in an amazing world right now. These you got to plug in car chargers. You could do that instead of a 30 amp car charger, or you could do the splitter. These are the most amazing things that are coming out now. These are battery backup. So this is called the Copper Charlie stove. This is an induction stove that has a built-in 5 kilowatt battery. And when you're cooking, it's running off battery. And when you're done cooking, it uses a little bit of power from the wall to charge that battery back up. And so you can cook a full-on, long-term, big family Thanksgiving dinner on this thing with no problems. And because it has a large built-in backup battery, it also has a 30% tax credit on it. So the reason why we would use something like this, I got a 100 amp house. They want an induction range as part of their full electrification. I'm trying to figure out how I can get a 50 amp breaker over to this thing. They want the car charger. They want the whole boat. They're living a full life. They want everything. And this is great because it saves money on the circuit. And once you put in the price of a circuit and the price of a standard decent electric range or decent induction range, this is a super high quality one. Not even something of this quality is going to be a couple $1,000s and a couple thousand and some change for the electrical circuit. By the time you got 4,500, 5,000 wrapped up into a standard wire and range, you can buy one of these for around $7,000, get a 30% tax credit, and you're almost money ahead. And if you're an I-type personality like me, you're going to bring all your friends over then, and you're going to tell them, look how fast I can boil water. And by the way, I'm not using any power right now. And so there's another thing that happens too, that we're also on this peak rate thing with our power. So between 4 and 9 p.m., we pay more for electricity. So if I've got a stove, most people I know cook between 4 and 9. Those big meals are a lot of power. We're going to pay, even if we don't want to, we're going to pay a little prime rate for that power to run our stove between 4 and 9. If I've got one of these, I'm running off battery. So I'm further reducing my costs. And now I'm charging up tomorrow or later on tonight when the power's cheap. So no brainer on one of these. I'm thinking actually of pulling my really nice LG range out and putting one of these in just because it's so freaking cool. Anyway, and this is the cooktop version of the same thing. So battery backup cooktop. This can also be done 120 volts. I mean, we're living in great times right now with the technology we have. Anyway, okay. So let's get into some examples from the field. We'll do a time check. We got about 30 minutes. Okay. I'm going to start talking really slow. Why don't the thing keep on coming over onto my screen? Okay. So examples from the field. Let's go into this a little bit. So got a few of these different things that we've done over time. Sometimes when you look at an electrical panel and you see these open things right here, these are not actually open. So you open the panel, you take the picture, and before you get a good feel for these, you go, oh, I got two open spaces on here, and you pull this thing off, and there's nothing to hook to there. It's the bus bar starts here. So be careful. Take the cover off if you're wondering about that. Okay, but be careful. Okay, so this house had existing 100 amp panel, as you can see here. It was an all gas house. They had gas dryer, gas water heater, gas furnace, gas stove. Um, the challenge on this was let's get all this going plus a car charger on 100 amps. The panel, we couldn't upgrade it real easy because it was over the meter, over the gas meter. Okay. The breakers were all screwed up and mislabeled. They'd had a bunch of different remodels in the house, and the loads were all weird. Um, they had one marked garage sub panel, and then they had the sub panel. It was just weird. So you can't count on any of this labeling being correct. You just kind of got to go with it. I've been caught up in this a couple of times. So what we ended up doing on this was we kept the panels the same because it was over the meter and it was going to be this long, arduous process because the utility company wanted to do the engineering and this customer wanted to get his job installed. So what we ended up doing is we put a simple switch in here off of one breaker. This simple switch ran a sub panel. Now, how did we do this? The sub panel, we ran the sub panel that went to the two heat pumps, and then we ran the other side to the stove. And so basically, the guy cooks an hour in the evening and a little bit during the day. His heat pumps just wouldn't run during that period of time. It wasn't until the following Thanksgiving that we got the phone call from him, and he says, "Hey, I want to get this process started on my new panel again." Because on that Thanksgiving, they were cooking a bunch of food and their heat pump wouldn't run the whole time they were doing it. So they had chilly house, warm food. So, but it got him going on it. And we did this as a temporary measure anyway. We have lots of these simple switches out there that are deployed as temporary measures until they get the main work done. So you'll end up with quite a few of these in your shop that are going to be repurposed. So this all happened actually. The simple switch was the range and heat pump sub panel. And we had a 25 amp heat pump, 30 amp heat pump water heater, and the induction stove was what we swapped over here. And we got them all nice and good. And you see, we had the extra wire ran. You see this wire just hanging here. This was the extra wire that we were going to run to the other circuit when we pulled this out. We went ahead and stubbed it into the old panel. So when he got his panel changed, we just dropped a breaker in. This wire was lived up, and we could separate these two circuits. So just trying to think about how to make it as easy as possible later is something you should keep in mind in these. Okay, so Petaluma, and this is an 1870 house that wanted heat pumps. So had to get a little creative on this one. They had a 125 amp panel, but they had a whole bunch of stuff. They had like two outbuildings, just all kinds of stuff. And you can see like this guy was he was pretty dialed in on his labeling. Like he went through and did the whole exercise of figuring out what everything was. Had a bunch of solar on the roof, 125 amp panel. We ended up getting rid of his gas furnace. We put in a 3-zone multi-split mini split system. So one in his office, one in his bedroom, and one in the living room. And this was one of those things. He's got a big giant house, two people living there. He wants a heat pump for the whole house. And I'm like, let's talk about how you live in your house. And found out like there was a bunch of rooms in his house he'd never used. And I says, why do we want to put a big giant heat pump in this house and heat up this whole house, this 1870 house that's just slightly better than Swiss cheese? Why do we want to heat this whole thing up? Let's just figure out how you live. And he says, well, I really live in the main living area and I work in my office and in his master bedroom. And I said, let's just put a system in that deals with that. Later on, if you decide to rent out those other two rooms, we'll put something else in for you later. So that was the solution on that. And we had to get a little creative because he really wanted a full ducted heat pump to replace his furnace. And we went with something that was a little different because of the energy situation. Okay, so multi-zone heat pump water heater, and then we insulated that house and air sealed a bunch. But if you've ever done air sealing on an 1870 house, we sealed up a bunch of stuff and probably only put it a small dent in what could have been done. But the cost of sealing up a house that's this old is just extraordinarily expensive, which was the other reason I talked him out of a full system. So if we put a full system in here and we address all these air leaks, let's just get these three rooms working good and go with that. So that worked out pretty good. And we put the 125, we put all that on his 125 amp. We did something that I normally don't do is well, two things on this. We installed this in an outdoor enclosure and my guys forgot to insulate it, so we had to go back and insulate it. But the other thing is this is a 120 volt heat pump water heater. It's worked fine for them because they have very low demand and it's a big enough tank. But I really don't like putting 120 volt water heaters in outdoor enclosures. And this is just a picture of the water heater in there. This enclosure got vented in two different ways. Um, and then, so that was a plug-in. We were able to save space there and we were able to just use the 220 volt circuit for his heat pump and got him all in under 125 amps. If he didn't have those two outbuildings, it would have been easier. But there you go. And his induction range. That was the other thing we got added in. Okay. That was a couple years ago. Okay, so this is a house, old 100 amp Zinsco, and getting battery installed on it. So installed the battery backup critical loads panel, the communicating bus for the battery to talk to the grid and do all of its fun stuff. This house, gas furnace, gas water heater, gas dryer, gas range, the whole gamut. I know this house really well. This is my house. When I moved into my house in 1997, I wasn't a heat pump guy yet, and I wasn't a building envelope specialist guy. So what I did was I converted all my electric stuff over to gas. So I had an electric range and I had an electric dryer, and I ran gas from my water heater over and I gasified everything because I thought it was great. And then later I ended up taking it all out. But fortunately, the wires were already in the walls because they were there when they built the house. So that worked out okay. Um, but I did full electrification, envelope, solar, and storage. The um, my pathway was a little different because I'm a contractor. I did the building envelope work, and it was kind of cheap. And my air conditioning system was only 5 years old. And so I kept my old air conditioning and heating system for a while after I did my envelope work. So I put windows in, I put ducts deep buried in the attic, air sealed my house to, a pretty decent ACH. And my existing HVAC system that I left in there was obnoxiously oversized after that. And it was just a pain to live with for many years. It was always freezing cold or hot in my house whenever the system was running. But the nice thing was is the house with a good enough envelope, the system didn't have to run very often, but it would literally in the middle of summer when it's 100 degrees outside, it was running 6, 7 minute air conditioning cycles. and we had to keep it at 79 because it got so freaking cold anywhere near a vent. So when I took that system out, I put one in that was significantly smaller, an inverter heat pump, saved 50% on my electric bill the first month. So in my house, because we live in a heating dominated climate, Vacaville, my air conditioning, even with a really tight house, good windows, my older air conditioning was using twice as much energy as my heat pump. So when I installed the heat pump, the savings from the air conditioner paid for the heating side. So my energy use for a full year is about what I was using just to air condition the house before. So that worked out really nice. That was a good surprise. And then I took out a tankless water heater and put in my first heat pump water heater. And everybody in the house was happier because I didn't have that cold water sandwich. I didn't have to go out and turn the button off because my son was taking 45-minute showers. He kind of adapted. And it's been fine with an adequate sized 65-gallon 120-volt air heat pump water heater. Um, then I added on to my solar after a little bit. So I've done a little bit over time, but I'm happy to report now the gas meter is no longer on my house. I'm fully electric, and my energy bills for the entire year last year were what my neighbor paid for 2 months of their um, air conditioning bill. I'm thinking this year it's going to be less because I did a couple other things. So, and then now I have an EV charger hanging here on the wall. I don't have an EV, but my daughter does, and I have a new grandbaby. So I bribe her to come visit by having her charge her car at my house. This is also, I put the span panel in my house. This is actually in my garage. The span panel in the garage turned into a complete garage remodel. I will recommend that, an inexpensive span install done by a contractor did turn into like $10,000 to remodel my entire garage. You don't have to do that if you're going to put in a span panel. I just wanted to make this a showcase because that's the way my head works. And so that ended up costing more, but that's kind of unrelated to electrification. So basically all low amp, low energy appliances. I do have a separate heat pump, 18,000 BTU wall mounted heat pump for my garage because we do party out there sometimes. And so my house is not lacking any electrical convenience whatsoever. And we don't typically work hard to conserve because everything's kind of covered. Like we can do whatever we want because it doesn't cost hardly anything to operate. Okay. All right. All right. So, excuse me, pre in Berkeley. This is a Berkeley one. And you can see another fastidious labeler we had here. Okay. So this gentleman, we had 125 amps. Once again, the whole gambit with all the gas appliances. He was looking for lower bills. His gas bill was insane. And so one of the things that we did in his house that was really beneficial is we got rid of a lot of the insulation in the attic, and we went in and did a really good sealing job. And when we were in the attic, we could look down from the attic and see down in his living room. Like he had these double doors and he had these massive air leaks in the house. And he wrote a review for us. It was like, even when my system's not running, my house is 100% better than it ever was. So just from doing some air sealing. So he was looking to fully electrify and get lower bills. Um, the challenge was physical space and capacity here. Like I got no room in this thing, right? These were all dead spaces here and here. There was nothing I could do with this panel. Um, he was looking at, we installed the heat pump water heater and the heat pump on that go round. And you could see his panel was just like full. So trying to get an upgraded panel wasn't something that was in the cards for him. So what we ended up doing was we put in this great heat pump water heater, and then we put a circuit splitter between the dryer and the water heater. And it was just one of those plug-in ones. And so this wire, when it runs over, kind of goes into the wall and goes back over where the other thing was, it actually goes into another switch that has a plug on it. And that plug actually plugs into one side of the splitter and goes up into a disconnect and then comes back over to this disconnect. So he just can't run his dryer and his heat pump water heater at the same time. This is about 3 years ago, so we've never heard that that's been a problem. And it's just two people living in a big house, and they were very conservative, environmentally conservative. So, um, and then we put the low amperage heat pump on the other side. I believe we put an 80 gallon in, or this is either a 65 or an 80. I can't remember. But we put a big capacity tank in because I knew whenever he dried his clothes, his water heater wasn't going to work. And sometimes you're going to use hot water to do laundry, and then you're going to do some drying. And there might be a situation where I did enough laundry this day that it didn't run enough. So we upsized the tank for him and made sure he had plenty of capacity there. And then I wish I had the air sealing pictures of this, but the air sealing in his attic space was just off the charts. And that's what made everything work. His load calc was the first one we had done in a long time where the cooling load in Berkeley was higher than the heating load when we figured in all the air sealing, which was really interesting. I believe we took out an 80,000 BTU furnace and put a 36,000 BTU heat pump in, if I remember right. Okay. All right. So Woodland. Oh, this is a great one. Okay, so Woodland, 100 amp panel, old Zinsco. Gas for same thing. Ran the gambit, including a Zinsco panel. So that was like the wild card on this one. Wanted to do full electrification. This customer is very interesting because in different areas we get customers that are kind of focused differently. But she was a lady that worked for one of the energy sides. And she had actually sent me an email that says, I can't wait any longer for your virtual assessment. I'm just going to keep moving along. And I sent her an email and I said, people that go with us generally see lower bills. We're going to look at everything. And she remade the appointment after she had canceled. And we ended up getting the job because she was really impressed by the thoughtfulness of everything going on the inside. So her issue was we had to keep costs to a certain amount. They didn't have a whole bunch of money, and her husband just got retired from a shoulder injury. And then the safety of the panel that we didn't really realize until kind of we started looking at things, and then the capacity limitations. This is one where you can see this older house. It did have a 50 amp breaker for the air conditioner, and we put on a system that only needed 20. So we got some space there, but we did end up putting in a nice, clean new sub panel for her as well. I don't know, but there's a picture. And then in order to get the EV charger and the stove in, we'd still, on that 100 amps, had to install the simple switch. So we have here is power coming out of a 40 amp breaker, one going to the range, one going to the car charger. She just can't charge her car if she's cooking. And then we ran the outlet over for the Emporia car charger, plugged that in for her. So she got everything she needed to do on a 100 amp panel. Her house is completely electrified. She made no sacrifices. She has everything she needs in her house. And just because of a little thoughtfulness. One of the things that she talked about from the previous contractor when we came out is that they wanted to put a new panel on the outside wall, which was over the gas meter, and bring in more power. And we were like, hold on, we don't need to do that. Let's check it out. Okay. So Davis, this is a good one too. So Davis, we ran into this thing. It was a 100 amp panel. And this is like another one of these. Can this really be trusted? Like, people have moved stuff around and like this has been relabeled a bunch of times. You just can't trust these, right? So it was a 100 amp panel. It was recessed into the wall. It had a feed wire that was capable of 125 amps. So my thing is, great, we'll pop a 125 amp main breaker right here. We'll be good to go. We're going to be sailing in clear water, right? So we did our whole upgrade. We popped in the 125 amp. We did the load calc on this thing. And if I can't remember, Alex could tell me, but I think it was 109 or 113 amps. It was very low, very slightly above 100 amps. So we had to go with a 125 breaker. Then the city inspector came out and said, you can't do that in this neighborhood. Call this number. The number was PG&E. And the people from PG&E said, oh no, all these lines in this neighborhood are all direct burial. If you want to upgrade that, you have to put the wire in conduit all the way back to the panel. It's going to cost you $30,000. And these people had all this beautiful landscaping stuff done. And the worst part about that is we had already done the work and then got this at the end, right? We kind of knew we were at capacity. So near gas meter, limited physical breaker space, additional capacity needed to meet. I might be out of order on that a little bit. Needed to meet electrical load count. Customer wants fast charging for future EV. So the solution on this one was a span panel. So we were able to take all of the circuits out of here, go into a gutter, put them all in the span. So basically what we have in this panel is only a 100 amp main breaker that feeds the 100 amp main breaker in the span. And then we were able to bring everything else in. Our solar lands in here. They can monitor their solar. I can't remember if this house had batteries or not. I don't see them. This one didn't have batteries. But one of the things that put us over on this house is this lady had a 120 volt kiln that she fired pottery in. And that needed a 30 amp 120 volt breaker. And that's just a weird outlying thing. And that just threw all our numbers off. So we did 120 volt water heater on this one. Got her induction range, got her 20 amp Mitsubishi system put in there. And then we went with a 125 amp smart panel. And then now, because she has the span, we can put her car charger on here with no problem. And we just get a span drive car charger and she's good to go. And that'll automatically throttle the car charger. It's like a circuit pauser built into the panel. So we don't need that. Because they wanted fast charging for their EV charger. They haven't called us back for that, have they, Alex? Anyway, so I'm going to have Alex is here. I'm going to show you this. He's actually doing a little tour of this, so let's check it out.
Hey everyone, Alex Sloan here with Electrify My Home. Really excited to show you guys around today. We're going to do a case study about good electrification, or what some call the Watt diet. So when it comes to electrifying whole houses, it all starts with the electrical panel. So if we have limited incoming capacity at the electrical panel, it's really important that we put out a plan that will allow a homeowner to electrify their whole house. Okay, so this was the original main panel for the house, okay, the main electrical panel. When we walked in, it's almost exactly how it is now, 100 amps of available service from the utility. So we actually came in and thought we might be able to bump that up to 125 amps, but after working with the utility, that wasn't going to work out. The other challenge from a utility perspective is that there was a gas meter.
Oh, what happened?
Standing
there
right here next to the panel, which is a no-no from a utility panel upgrade perspective. And so several challenges, right? And if we needed to trench to get out the existing wire and upgrade the wire so it's capable of holding 200 amps, which is the current standard, that would be extremely costly. So what did we do instead? Instead of going through the utility upgrade process for a panel, we went ahead and made some important and strategic decisions with respect to what appliances we spec'd for the project, what electric appliances we spec'd, as well as putting in this span smart panel. So this span smart panel has a nice sleek design. This is the panel of the future. It is a smart panel. It's going to intelligently assess if your house is ever getting up near 100 amps or whatever you set it to. And from there, it will strategically shed certain loads that the customer picks to ensure that the house is never going to be in the danger zone with respect to available capacity on the panel. We've got our Mitsubishi inverter heat pump. So when we're playing the Watt diet, it's really important to prescribe equipment that's going to be as power efficient as possible. This unit, it's a 24,000 BTU unit. We know that's the size because we did a thermal load calc. We don't guess on this stuff. We put in exactly what the house needs. 24,000 BTUs, this only requires a 20 amp breaker, right? So in addition to not taking up much room in the panel from a capacity perspective, it's going to optimize the customer's energy bills for as long as the system's in the house. All right, here we are at the indoor unit for the HVAC system. This is the Mitsubishi multi-position air handler. The outdoor unit powers the indoor unit, so there's no separate circuit required for the air handler. Here we are at the induction range. Induction ranges can be fairly power intensive. This requires a 50 amp circuit. We have a frigid air model, beautiful, works great, and has the controls up here in the back. So lots of great features on this particular unit. So the 120 volt heat pump water heaters, they have just a heat pump mode compared to the traditional 240 volt models, which have a heat pump in addition to a couple of electric resistance elements to boost up and speed up the recovery. So in this case, we wanted to be as power efficient as possible and found that the traditional 240 volt unit just, it wasn't necessary. One of the most underrated features of a Watt diet plan is attic insulation. It's so simple. We just got to do it. By installing attic insulation and bringing it up to code, as well as burying the existing ductwork in attic insulation, which is important in a dry climate, we were able to downsize this HVAC system capacity from 3 tons to 2 tons, alleviating a ton of panel capacity. So that's the nice thing about insulation, is it keeps the house nice and evenly tempered all throughout. Keep that heat inside the house. Don't let it escape to the attic.
All right, give it up for Alex there, man.
Yeah, that was
Anybody
great.
want to watch
That was
Gomez Adams? Okay. Okay. All right. Yeah, that a great narrative on that, right? Okay. Um,
Hey,
okay. All right. So we have another training coming up. We're a couple minutes early. Sorry about that. But we got a whole bunch of information out there in that amount of time. So I'm curious if there is any questions.
we had a lot of great conversation happening in the chat. Really appreciate everyone's contributions and insights. Any questions for Larry and Alex? You can either type them in the chat or speak up.
While that's coming through, Larry, there was a comment in regards to putting splitters on compressor-based systems. So it just says that, caution about putting heat pump, HVAC, or water heater on a simple switch that the heat pump could abruptly shut down. Another HVAC professional told me the compressor inside the heat pump won't like this. If it happens a lot, the compressor might fail a little bit faster. So any comments on that? My response was we do try to avoid installing splitters on any compressor-based systems whenever we can. And the one example of the HVAC system was very temporary in the one we showed here. And we've got a half dozen on heat pump water heaters out there, and so far those have all been flawless, no issues, no early deaths on those.
Yeah, I think probably if we think about it, the heat pump water heaters are not inverter compressors. I could see where if we drop power to an inverter compressor and it didn't ramp down, that could be an issue. But yeah, so to just expand on what Alex was saying is mostly anytime we've ever done a splitter on a heat pump itself, it's always been as a temporary measure to get to where we get the panel installed or we get the next phase of the operation going. So a lot of times what we have to do in order to keep projects on schedule, keep customers getting what they need when they want, and then we get the roll of the dice of the utility company, is we have to electrify things using splitters in order to get the gas meter removed so we can go back in the same spot. So a lot of those are temporary for us. Most of the time when we're doing splitters, it would be a dryer and a car charger. And that's going to be like on a Neo charge. I think we have one out there that's gotten split that we showed. And then the simple switches mostly for car charger and stove. Those are the ones that always kind of throw us for a loop when we're trying to upsize the electrical and keep them on 100 amps. So thank you. Good advice on that. All right. So I hope everybody got something out of this today. We are having, as you see on your screen here, if anybody just doesn't have anything to do and doesn't mind driving to Bakersfield, who doesn't want a vacation in Bakersfield for 3 days? We do have our tech electrification training coming up next week, Monday through Wednesday. I think there's a couple slots left in there. And that's paid for through Tech Clean California. So it's a no cost to you training. It does, if you go to this training program, if you hadn't been through it before, it does open you up to be able to participate in our cohort program, which is a 12-week meeting on Fridays, where we bring a guest speaker in from the circles of electrification. So a lot of our guys have said, hey, we heard about stuff that was 2 years in advance. So You can do the cohort training, and you could potentially participate in our on-site training, where we'll come out and get your service techs all dialed in and excited about electrification, start saying the right things to the customers. So by going to this class, it does open you up for opportunities for additional training, and it's a really fun class, by the way, too. They're cool. Yeah, we know it's a good class because when it ends on Friday, we still have people sticking around for like an hour after the class on Friday afternoon. So, fun class, good stuff if you're into it.
Yep. And I can definitely vouch. You can see in the middle row to the right is the training that we at 3C Ren did with Alex and Larry and Oxnard. It was, I can vouch for it being extremely engaging, informative, and a really great time. I mean, we nearly got kicked out of America's Job Center because we were back chatting so much after a good 2 full days of training. So definitely take advantage of this opportunity. And I think there's another slide, Larry, of some other
All right. You know, it's a
3C
good
Ren.
class when you have to tell people, like, the class is over, guys.
Yep, exactly. Yep. And I
All
think
right.
there's another slide, Larry.
All right, got one there. And then
Yep.
join us on 520 or 56 for electrification products for the Central Coast. And then here we go. We're going to close it out.
Yes, closing it out. So continuing education units are available. That's my email, Juliana@3CRen. If you registered with your AIA or ICC numbers and you did in fact attend at least 80% of this webinar, I'll automatically do that. For folks who might have called in or registered with someone's account, feel free to email me. There's going to be the slides of the recording will be sent to you. I see a lot of really great feedback in the chat, which is so appreciated. But if you wouldn't mind taking that survey and letting us know how awesome it is to have folks like Larry and Alex giving us their real world in the field experience and expertise. Those are a couple more, and we have tons of other trainings and events. Some webinars, some in person. So check out our calendar events on 3C Ren's website. So with that, just want to say thank you again to Larry and Alex for providing this phenomenally informative and interesting webinar today. I definitely learned a lot, and I hope you all did too. And we appreciate all of you taking time on your Tuesday evening to come out, and have a good evening.
Yeah, just to add on that the training in Bakersfield, you can get your energy badge from Department of Energy by going through that class and qualifying. And it also carries BPI and NATE CEUs, a lot of them. Okay. Thanks, everybody.
Yes,
It's been awesome.
absolutely. Yeah, this was so great.
All right. See you later, Juliana.
Yeah, see you, Larry.
All right.
Thanks, Alex.
Bye.